The moon has been a focus of human mythology and a topic of general interest since the beginning of recorded time. It has captivated observers across all cultures. As first humans set foot on the moon, they gave us awe-inspiring glimpses of our nearest neighbor. But we know that just a part of the picture of the moon still hides many things we don't know: mystery, science, and intrigue. That's the words NASA used to describe the far side of the moon, a region full of deep craters engulfed in unending darkness. The far side of the moon has a certain mystique about it. It's eternally out of view, never facing the Earth, which has earned it a misleading nickname, the dark side, as if sunlight never reaches its surface. It's the section of the moon we'll never see for ourselves, not unless we hop on a spaceship and fly over there. But compared to the rest of the population, very few people have ever had the privilege of walking on the moon. And of those who have left their footprints on the surface of the moon, only a few Apollo astronauts have ever seen the elusive far side. For many years, these astronauts kept what they discovered under wraps. But now they finally broke their silence, revealing the shocking secrets that could upend everything you were told about the moon. Stay tuned as the legendary astronauts shed light on the far side of the moon. The moon shows us its smiling man-in-the-moon face every month, illuminated by the sun to varying degrees over the course of its orbit around us. However, thanks to its orbital dynamics, we only get to see that one hemisphere from Earth. The other hemisphere, the far side, is constantly concealed from us. Well, that's not strictly true. Libration, which is the gentle wobbling of the moon in the sky caused by changes in its position in its elliptical, i.e. non-circular, orbit around the Earth, mean we can catch glimpses of small slivers of the far side. We can see actually about 59% of the moon's surface from Earth at different times of the year. But until the first space missions to the moon flew around our natural satellite, what lay beyond on the far side was a mystery. It's often mistakenly thought that the far side of the moon is in darkness. Rather, it experiences day-night cycles just like the near side. When we see half of the moon being illuminated by the sun, giving it a half or crescent shape in the sky, half of the moon on the far side is being illuminated at the same time. When the moon is new, the far side is in full daylight instead. When the moon is full, it's nighttime on the far side. The reason we only see the one face is because of the phenomenon known as tidal locking. The moon rotates on its axis roughly once every 27 days, which is the same amount of time it takes to orbit the Earth. This means it is rotating at a rate that means we always see the same face, more or less, as it moves around Earth. There are 2 weeks of daylight and 2 weeks of night on every spot on the lunar surface. Charlie Duke, who is the lunar module pilot of the Apollo 16 mission, said, "It was early morning during the moon day at the Apollo 16 landing site, which was called Descartes. We were the 5th mission to land on the moon, and I can say that it really is a dramatic place." Our first glimpse of the mysterious far side came early in the space race, courtesy of the Soviet Union's Luna 3 spacecraft almost 60 years ago. In 1959, barely 2 years after placing Sputnik 1 in orbit, Russian engineers managed to send the spacecraft, which was crude by today's standards, into orbit around the moon, and, for the first time, we got a good look at the mysterious far side. Luna 3 took 29 film images of the far side in total, which were photographically developed, fixed, and dried on board. Remember, this was long before multi-megapixel cameras were in operation. Ironically, the film used had been stolen from American spy balloons, as it had to be sturdy and radiation hardened. The spacecraft, using a combination of 2 camera systems, one wide field and one narrow field, but higher resolution, and a crude onboard scanner, could then transmit the processed images, which were spot scanned from the photographs, back to the receiving station in the former Soviet Union. Although only 17 of the 29 taken were transmitted successfully back to Earth, of which 6 were considered good enough for publication, they proved to be a revelation. Those 6 images covered 70% of the far side and opened a whole new perspective on the lunar surface. It was almost immediately evident that the dark patches that make the face of the man and the moon on the near side are almost completely absent on the far side. These dark patches are basaltic plains called mare, created by volcanic activity on the moon billions of years ago. Instead, the far side was littered with craters, even more so than the near side, and some of those craters were the size of small countries. The Soviets started naming many of the features they were seeing for the first time, an act which caused some controversy in what was known as the height of the Cold War era. We already had an inkling of one of those vast craters, which is actually one of the very few mare on the far side. The subtlest hint of Mare Orientale, one of the largest impact craters known, seen on the limb of the moon, had been known of since its discovery by Julius Franz in 1906, and can be seen during good librations when that portion of the moon swings around towards us. The view from Luna 3 showed us how vast an impact crater Orientale was, resembling a bullseye. It was almost 560 miles, that's 900 kilometers, across, pretty much the length of the United Kingdom, give or take, and was caused by an asteroid impact, thought to be around 40 miles or 64 kilometers wide, just under 4 billion years ago. The resulting giant crater, termed an impact basin, was subsequently filled with volcanic lava. In 1965, another Soviet mission, Zond 3, flew by the moon with a far better camera than Luna 3 possessed, and with the ability to conduct more detailed science observations, including spectroscopy. Zond 3 produced 23 very detailed photographs of the Luna far side, which enabled one of the first detailed maps of the entire lunar surface to be constructed. In the meantime, NASA was progressing its Apollo program at a phenomenal rate. The Apollo program grew out of the space race, a contest that began in 1957 between the capitalist US and the communist Soviet Union over superiority in space. With the Russians ahead during the start of the race, US President John F. Kennedy challenged the newly created NASA to land men on the moon and return them safely in his famous 1961 moon speech at Rice University in Texas. Preparation for Apollo came from NASA's Mercury program, which ran between 1959 and 1963, and sent one-person crews into orbit to see if humans could survive and work in space. That was followed by the agency's Gemini program, which ran from 1962 to 1966, and included two-person missions that tested many maneuvers and components critical for landing on the moon. The Apollo program required a monumental effort, employing roughly 500,000 people in the United States, according to Spaceflight Insider. The program cost a whopping $28 billion over its lifetime, or approximately $283 billion when adjusted for inflation, according to the Planetary Society. Following the declaration by President Kennedy that the U.S. would place a man on the moon and return him safely to the Earth by the end of the 1960s, by December 1968, NASA was ready to send 3 people, Frank Borman, Jim Lovell, and Bill Anders, all the way around the moon and back for the Apollo 8 mission. They became the first humans in history not only to escape from low Earth orbit, but also to see the elusive far side of the moon. This is how Lovell famously described the lunar surface. The moon is essentially gray, no color, looks like plaster of Paris or sort of a grayish beach sand. We can see quite a bit of detail. There's not as much contrast between that and the surrounding craters. The craters are all rounded off. There's quite a few of them. Some of them are newer. Many of them look like, especially the round ones, look like they were hit by meteorites or projectiles of some sort. When the Apollo 8 spacecraft flew around the far side of the moon, the signal to Earth was cut off for around 10 minutes. This Loss of signal was a daunting time for the flight crew and mission control. Apollo 8 was alone and truly cut off from Earth, venturing where no human had ever gone before. As the astronauts came back around from the far side, a collective sigh of relief was breathed by many of the flight team at Mission Control in Houston. Charlie Duke describes what it was like to be flying over the far side of the moon. He said, "The computer told us that we were out of contact with the Earth and that we had lost a signal," he says. "Then all of a sudden, there was the sunrise. It was the most dramatic sunrise I've ever seen. In Earth orbit, you can see the sun's glow on the horizon or the planet's atmosphere, and it gets brighter and brighter. The moon is different though. There's instant sunlight with long shadows on the lunar surface. The far side of the moon was very rough back there. I would not have wanted to land on the back side of the moon," he said. After the success of Apollo 8, Apollo 9 went back to vital low Earth orbital testing of the lunar module, so the next astronauts to visit the far side were Gene Cernan, John Young, and Tom Stafford on board Apollo 10 in May of 1969, just 2 months before the historic landing of Apollo 11. However, while flying over the far side of the moon, the trio of astronauts encountered something strange, which in the last few years NASA has been forced to re-explain thanks to conspiracy theory documentaries airing on U.S. television. The facts had been well known since the 1970s. These strange events on Apollo 10 were manifest in the form of some very odd sounds. The radio systems on board the Apollo spacecraft were crude by modern standards, though state-of-the-art at the time. The command and lunar modules were relatively noisy environments, according to most of the astronauts, with bumps and bangs combining with the whirling of fans and engine noise. What the Apollo 10 crew heard, though, through the radio system, baffled them. They described it as being almost like that made by an electronic instrument called a theremin, often used in creepy science fiction B-movies of the 1950s and 60s, as well as on the Beach Boys' song Good Vibrations. Throughout that time, the astronauts discussed the strange music. They said, "That music even sounds outer spacey, doesn't it?" one of the astronauts asks. "You hear that? That whistling sound? Boy, that sure is weird music," lunar module pilot Eugene Cernan says in the notes. "We're going to have to find out about that," his colleague command module pilot John Young says. So far, it still isn't clear where the strange sounds were coming from. Particles in space might have interfered with the astronauts' radios, scientists have suggested. The Cassini spacecraft picked up the same sounds from Saturn, though the charged particles in that case came from moving through Saturn's environment. But the moon doesn't have an atmosphere or magnetic fields. The sounds might also have come about as the two radios interfered with one another. But astronauts have suggested that the scientists would have been used to hearing those kind of sounds. With the onset of the moon landings, 2 astronauts would travel to the surface with a third remaining on board the command module to orbit the moon alone, though all of them got a chance to orbit the moon and see the far side before landing. The solo orbital journeys of Michael Collins, Apollo 11, Dick Gordon, Apollo 12, Stuart Roosa, Apollo 14, Al Worden, Apollo 15, Ken Mattingly, Apollo 16, and Ron Evans, Apollo 17, who are the unsung heroes of the Apollo missions, are some of the bravest feats ever achieved by astronauts. They would spend days making quite detailed lunar observations from orbit, mapping features nobody had ever seen before. Al Worden is often quoted as saying that his time alone was some of the best time he had had during Apollo 15 mission. It was nice to be rid of those guys, as you can imagine. Being stuck in something the size of a family car for over a week, it got pretty crowded up there. Once Dave, Scott, that is, and Jim, Irwin, left, I felt like I had some real space to start to do my important work of mapping the lunar surface. But the far side, the views at certain times, when the sun and the earth are blocked out, are like nothing you could imagine. The sheer number of stars you see is incredible. It's like a sheet of white, and you know that every single one of them is a sun in its own right. A question often asked of the Apollo astronauts and flight team is, why were all the missions just to the near side? We wanted to be in contact with the Earth, so we weren't able to land on the far side of the moon, says Charlie Duke. Should something have gone wrong while the astronauts were on the surface, they would not have been able to communicate directly with Earth. This would not be such a problem today, though, as satellites could be put into lunar orbit to relay communications from the far side. The far side is of growing interest to scientists and potentially future planned human missions. Indeed, the possibilities for the far side of the moon are vast. For many decades, the astronomical and scientific community has wanted to put radio telescopes and optical telescopes on the far side of the moon. Observatories on the far side would be shielded from not only man-made radio interference from Earth, but also the glare of daylight on our planet. The telescopes could be built inside craters to avoid solar radiation, and would provide us with an unprecedented, clear insight deep into the far reaches of the universe. We also have little true understanding of the processes that make the far side so vastly different in appearance to the near side. Why is it so scarred, with impact craters, and so lacking in volcanic mare, is even more puzzling when you consider that when the moon formed, it was much closer to Earth, and may not have necessarily been tidally locked at that time, meaning there would have been nothing special about the hemisphere we dubbed the far side. For years, space scientists have been captivated by the moon's south pole. The region is full of deep craters, engulfed in unending darkness. As NASA states, extreme contrasting conditions make it a challenging location for Earthlings to land, live, and work, but the region's unique characteristics hold promise for unprecedented deep space scientific discoveries that could help us learn about our place in the universe and venture farther into the solar system. Space experts believe the lunar surface's south pole hosts a vast reservoir of water ice in permanently shadowed regions. The presence of water is of immense significance for future space exploration, as it can be converted into resources such as drinking water, oxygen, and hydrogen for rocket fuel. Moreover, the South Pole witnesses extremely cold temperatures. This means that anything trapped here would remain frozen in time, without undergoing much change. The rocks and soil in this region could therefore provide clues to the early solar system. Girish Lingana, space and aerospace expert, also explained that the South Pole is located in the South Pole Aitken Basin, which is a huge crater. This makes the South Pole a geologically interesting place because it is possible that there is material from the deep crust and upper mantle of the moon on or near the surface. The South Pole is also a more promising place to look for ice than the North Pole, he was quoted as telling The Week. There are other reasons for accessing water on or just below the moon's surface. Many countries are planning human missions to the moon, and astronauts will need water for drinking and other purposes. Transporting equipment from Earth to the moon involves overcoming the Earth's gravitational pull. The larger the equipment, the more rocket and fuel load would be needed to achieve a successful landing on the moon. The new commercial space companies charge around $1 million to take a kilogram of payload to the moon. That's $1 million per liter of drinking water. Space entrepreneurs no doubt see lunar ice as an opportunity to supply astronauts with locally sourced water, says Professor Simon Barber, a planetary scientist at UK's The Open University, who also works with the European Space Agency to the BBC. But as the saying goes, good things are hard to come by. And that's exactly the case with the moon's south pole. The terrain on the South Pole is difficult, and the low temperatures are also a problem. Several parts on the South Pole lie in a completely dark region where sunlight doesn't penetrate. Also, temperatures fall to as low as below 230 degrees Celsius. The lack of sunlight and extremely low temperatures create difficulty in the operation of instruments. There are also large craters on the South Pole, some a few centimeters in size, while some are as large as several thousand kilometers. Even a former ISRO chief had highlighted several concerns about landing on the south pole of the lunar surface during the Chandrayaan-2 mission, saying there would be 15 minutes of terror for the space agency before touchdown. Regardless, according to Manish Purohit, a former ISRO scientist involved in the Mangalyaan and Chandrayaan-2 missions, most lunar missions target the Moon's south pole as the landing site because the lunar poles harbor an environment that represents the remarkable diversity on Earth and are strikingly distinct from the familiar middle latitudes. The craters, untouched by sunlight for billions of years, offer an undisturbed record of the solar system's origins. According to TV Venkateswaran, a scientist at Vigyan Prasar, an autonomous organization under the Department of Science and Technology, the presence of water on the lunar south pole is of immense significance for future space exploration. It can be converted into resources such as drinking water, oxygen, and hydrogen for rocket fuel. Also, the permanently sunlit area in the region has a temperature of around -50 to 10 degrees Celsius, which provides better chemical conditions for the electronics on board the rover and lander to work properly, he told. And most recently, with a primary aim of putting a lander and a rover on the Moon's highlands near its south pole, Chandrayaan-3 has made India the first country to softly land a spacecraft in this particular region. India is now the fourth country to achieve a soft landing on the Moon, after the United States, the Soviet Union, and China. Previously, Luna 25, Russia's first moon landing spacecraft in nearly half a century, crashed into the Moon after reportedly spinning out of control. Meanwhile, the U.S. is said to be planning a crewed mission to land humans at the site in 2025. China is also planning a mission to the area before the end of the decade. When humans do eventually return to the Moon, the far side of the Moon must be a goal for landing. Understanding it will give us more insight into not only the Moon's past, but also perhaps the Moon's relationship with Earth and our own past. Well, that's all the information we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit that bell so you never miss out on future episodes. And be sure to tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we'll see you next time.